software engineering. Our discussion on process model is continued. In last lecture, we talked about the process model in general, and then we discussed the selection criteria for choosing a particular process model for a project. And then we discussed the build and fix model and its strengths and weaknesses. We also discussed waterfall model in detail in last lecture. And also we discussed some of the problems or issues that basically are in the waterfall model. And we discussed the advantages of the waterfall model as well. And at the end, we talked about that when can we use a waterfall model. So in today's lecture, we're going to talk about the V-shaped process model. Now these are the topics that we are going to discuss. V-shaped process model. First of all, we will look at the definition of the V-shaped process model, and then we will talk about the verification and validation. Remember students that verification and validation is also the second name of the V-shaped process model, and like V and V. Phases of V model, we will talk about the phases of V model. We will also talk about the problems in V model and advantages of V model, and then at the end we will look at when to use V model. These are basically the references. So software engineering, a practitioner's approach, chapter number 2, and the another book, the N. Samavela, written by N. Samavela, chapter number 4. The objectives and outcomes, again, they are basically the main objective of this chapter is obviously to introduce you guys to the software process and to the software development life cycle, and also to the software process models. They are basically coherent set of activities for the software production or for the software development. After the end of today's session or after the end of today's lecture, you would be able to understand the process model in general, okay? And then you would be able to understand, analyze V model or V process model, and understand and learn phases of V model, advantages and disadvantages of V model, and then when to use V model. At the end, you will get the analytical skills after the end of this session. Now, let's talk about the V-shaped process model in general. That V-shaped process model is same like waterfall model, because the phases in waterfall model and in the V model, they are sort of the same, okay? Except there are, the flow is changed, because after the coding, V model basically bent upwards to the testing phase or to the quality assurance activity. We will talk about them later, but let's have a look at the different points here. The V model is a type of SDLC model where process executes in a sequential manner in V shape. Now, basically here, the software process or the process that we apply for the software development, that is basically executes in sequential manner. It means one by one, or a sort of, we cannot say a linear, but a sort of a sequential manner, but in V shape. So this is also known as verification and validation model. We will also look at the verification and validation in coming slides. That what does this mean? It is based on association of testing phase for each corresponding development stages. Now you have to keep this thing in your mind, that the main difference between the V-shaped model and the waterfall model is these testing phases, because here testing is introduced well before the coding phase. Testing in V-shaped model is introduced well before the coding phase, while this was not manifested in the waterfall model. Fourth point says development of each step directly associated with the testing phase. Again, the same thing, that for example, for the requirement, when we are collecting requirement, at the same time we produce a testing document as well for the, and we call that document as acceptance test design document. And then later on for the system design, we also produce system test design document, and then for the module design we also produce. So basically here the main focus is on the testing. Now the next phase starts only after completion of the previous phase. As we have discussed in waterfall model, this was the same thing that we discussed in waterfall model as well. Because what we discussed in waterfall model, that we cannot start a phase until the previous phase is totally completed and until the phase or the previous phase is signed off. So the same way in V model, we do not start the next phase until the completion of the previous phase. That is, for each development activity there is a testing activity corresponding to it. Now again the same thing, that there is basically a testing activity associated with each of the activity that we are performing for the software development. V model is evolved from waterfall model because there were some problems in the waterfall model. That's why here we basically we can see that V model is basically derived, or it is evolved from waterfall model. Completion of each phase before the next phase begins. Now this what we discussed, this point we discussed above here as well, that the next phase starts only after completion of the previous phase. Instead of moving in a linear way, process steps are bent upwards. Remember that waterfall model phases were to be followed in a linear fashion. But here the difference is that these process steps or the activities that we perform or we execute for the software development, they basically bent upwards after the coding. When you see or when you see the diagram of the V model, then you would understand this point. V model is basically defined by the late Paul Rook in 1980s, because waterfall model was introduced in 1970. So this V model, it was basically introduced in 1980s to improve the efficiency and effectiveness of software development. The main purpose of the V model is that we basically improve the usefulness of the software development process. Accepted in Europe and UK as an alternative to waterfall model. Still, there are many agencies that are basically using this V process model for the software development, especially the German Defense Ministry. They are basically applying V model for different projects, and similarly it is also applied in UK, in different agencies in the UK as an alternative to waterfall model. Now, because this model is also called as verification and validation, so verification, now you have to know the difference between verification and validation. Basically, verification deals with all the documentation that is done before the coding, and validation is actually the real testing, or in other words, we call the validation is the dynamic testing, because the in validation we test the coding, the code that we have written, but the verification phase, what we do, we basically produce the document, and then all those documents which are produced in the verification phase, they are basically validated in the validation phase. So let's see the difference between verification and testing. Verification and validation testing. It involves static analysis technique. Now the static analysis technique is basically review done without executing code, because here, as I told you, that we will produce documents, okay, and that's why these documents are basically also called as static analysis technique, because we review all the documents that are produced at each activity of the software process. While if you look at the validation, it involves dynamic analysis technique. Now this is static analysis and this is dynamic analysis technique. Functional, non-functional testing done by executing code. So basically in execution, in validation, we execute the code and we find errors if there are any in our code. So that's why we call it dynamic analysis technique, while verification is static analysis technique, because here we would not produce the real coding, only the documents or the documents are produced here in the verification, while in the validation real coding is tested. It's a static practice of checking the documents design in code. Whatever we produced, the work product that is produced, that is basically reviewed or it is checked in a verification phase. So that's why we call this process as static practice, while this validation is basically dynamic practice of validating and testing the actual product. Here we are because the product would be produced in the validation, okay, and then the product will be tested. It means the real code would be tested. It does not involve code execution. Now validation involves code execution. Verification is human-based checking of documents and files, while it is computer-based checking of programs. Whatever programs we might have written in the software product, that would be checked here, that would be tested here. It uses walkthroughs, inspections, and reviews. Walkthroughs, inspections, and reviews, they are basically software quality assurance activities, and they are just a sort of review. Walkthroughs and inspection, they are sort of review where we check all the documents that is produced at each activity of the software development process. Now in this in validation, what we do is we use black box and white box testing. There are two techniques normally used in the software testing. In black box testing, we check the functionality, while in white box testing, coding is checked. All the logical errors or whatever the syntactical errors or the semantic, they are basically tested here in the white box testing. It is done by the quality assurance team. It is done by the testing team. It is done before validation and it is done after validation. So these are the few points that you have to keep in mind. Let me summarize this verification and validation. Remember that verification is done before the coding. Validation is done after the coding. In verification, when we produce all the documents, okay, then the documents are verified. It means the documents are tested. And similarly, in validation, we check the real code because coding would be produced, and that's why this validation is done after the coding phase. Now, this is the diagram of the V model. In the diagram, you can see that here we have the requirement analysis. When the requirements are collected at the same time, we will produce a document, okay, and that document would be called as acceptance test design. And this document is produced according to the requirements that we have collected in the first phase of the software development, okay. In the next phase, system design would be produced, okay. System design would be created, and at the same time, system test design document will also be produced. In system design, we partition the requirement to hardware and software. All the architecture or the system architecture is created here, and at the same time system test design document is also produced at this particular phase. And after this, the architectural design of the software is created. It means we would partition the software into multiple components or into multiple subsystems. Once these are partitioned into multiple subsystems, then the relationship among each subsystem or among them is also basically identified here in the architectural design. At the same time, integration test design document is also produced here in the architectural design. And from there onwards, the module design, the low level design is produced. Remember that this low level design, the data structure is basically identified, all the algorithms are identified, and at the same time unit test design is also produced in this phase. So just like waterfall model, you cannot go back from one phase to another phase. It means that dynamic changes are not possible. There is no iteration of phases. Just like waterfall model, each of these steps, they are basically executed in a sequential manner. Once the module design is completed, then we will move to the coding phase. Remember, after once we write all the features or all the programs of software, then the unit testing will be done, and unit testing will be done according to the unit test design document that we produced here during the module design, where each individual unit of the software will be tested. Once we perform the unit testing, okay, the process steps will move upward to the integration testing. Now, what we do in integration testing, remember that integration testing will be done according to the test design document that we produced here during the architectural design of the software test of the software design or of the software system. The integration testing is done according to the integration test design document, and this design document is basically produced here in the architectural design of the software system. And after the integration testing, system testing is done. Now system testing is done according to the system test design document that is produced here in this phase of the software system, that is system design. When we are creating system design, okay, at the same time system test design document will also be produced, and then the system will be tested according to the document that we produced here in this phase. From here upward, we move towards the acceptance testing. Remember, acceptance testing would be done by the customer, and this acceptance testing would be done according to the acceptance test design that is basically produced in the requirement analysis. So this would give us a criteria for accepting the software system. Now this is how the V model works. All the phases are basically they are followed in a sequential manner, but after the coding you can see the phases, they are bent upwards. So this is, on the right side we have the validation, and on the left side we have the verification. All the documents, test documents, review, inspection, walkthrough, they are done on the left side, while on the right side what we have is that we have the validation, because we will have produced the different features. It means we will have coding in our hand, and then that coding will be tested on this side of the software development process, and the coding would be tested. All the testing activities would be done according to the documents that we produced on the left side of this process activities, which is also called as verification. Now these are the general phases of the V model. Remember that as I told you that first of all we have to collect requirement, and then requirement would be analyzed for the verification. This phase contains detailed communication with customer to understand their requirements and expectations. Now, as I told you when we were discussing waterfall model, that the requirement analysis is basically done just for the collecting requirement and requirements of the system, and then they are analyzed. This stage is known as requirement gathering. So we also call it requirement gathering, because first we have to collect requirement, then requirement would be analyzed, then specification would be produced, a document would be produced, and at the same time the acceptance test design document will also be produced here in this phase. System design. Now system design, this phase contains the system design and the complete hardware and communication setup for developing product. All the network, what sort of network would be used, how the customer is going to access the software, like all these things would be done here. The communication setup would be done here in the system design. So after the completion of system design, we would also produce system test design document here in this phase. Now once this phase is completed, then the architectural design would be created. Architectural design of the software would be created. System design is broken down further into modules taking up different functionalities. As I told you that here the software would be basically broken down into smaller subsystems, and then the data transfer and communication between the internal modules and with the outside world, other systems is clearly understood. How the user is going to use or how the user is going to communicate with subsystem, how one subsystem would be interacting with other subsystem. So the communication is basically done here in this architectural design. And at the same time, we would produce integration test document as well. Here module design, in this phase the system breaks down into small modules. Now this module design is called as low level design because the data structure is defined in the module design. The algorithm is also designed here in the module design. In this phase the system breaks down into small modules. The detailed design of module is specified, and this is also known as low level design. So at the same time we would produce a unit test design document as well here in the module design. Once this is completed, the next phase would be the coding phase. Now the actual coding of the system modules designed in the design phase is taken up into the coding phase. The module design that we would have done here in the module design, that would be basically the coding would be written for the module that we have produced here in the module design. The best suitable programming language is decided. Whatever the programming language we're going to use, that would be decided in this coding phase, and then the coding is performed based on the coding guidelines and standards. All the formats, the rules, and the methods for the coding would be also discussed here in the coding phase in order to ensure the quality of the software features. Now once the coding phase is completed, then we would start the unit test. Remember that unit can be as small as a class itself. So we know that if we are developing software system using object oriented paradigm, then we have to produce classes. So remember that unit can be as simple as class itself. Each class will be tested, the functionality of the class will be tested, input and output of the class would be tested, okay. Or even unit can be a subsystem as well. For example, we test the attendance system, or we test the login page, okay. So that login page is an example of one unit. The most micro scale of testing, it is basically the very low level of testing. Units are tested in isolation because remember that we would partition the software into multiple units. In these, every module or every unit of the software system would be tested separately or in isolated manner, and then ensures the component is working according to the detailed design build specification of the module. Remember, because in module design, okay, we would create module or that module design is basically the detailed design or low level design. And in the unit testing, each module would be tested, its functionality will be tested. Similarly, in unit testing, we would need the unit test design document as well. So each unit will be tested according to the unit test design. This is also known as component or module or program testing. Here, this unit testing is basically done here at the very bottom of this system testing life cycle. Then we have integration. Remember, students, that integration means to combine two or more than two things and then checking its behavior. So integration testing, what we do in integration testing, we combine different units. Remember that unit testing would be applied on each individual testing, while integration testing, it would be applied on the integrated modules or in the integrated units. The testing of more than one tested unit together to determine if they are function correctly. For example, you can check this box as one unit. So in unit testing, we would individually check all these different units, okay? And then in the integration testing, what we do is we basically combine or we get together these different units and then check their results, that whether they are working, that whether these units are working when they are combined or not. So it is done using the integration test design prepared during the architecture design phase. Now this integration testing is done, it is done according to the integration test design document that we produced in the architecture design. Helps assembling incrementally a whole system. Here, basically, the an integration system, it helps us in combining or in assembling each increment and then to get a whole or to get a complete system, ensuring the correct flow of data from the first through the final product, from the first through the final component. So as I told you that here we check the combined effect of all these different units, and they are basically done by the developers, designers, and testers in collaboration. Now here we involve the developers, designers, and testers. Also called interface testing or assembly testing. We can also call this sort of testing as assembly or interface testing. Then we have this system testing. Remember that once the integration testing is completed, the next testing that is done is the system testing. System testing is done according to the system test design that is produced during the system design. So testing the system as a whole, now the whole system would be checked. Remember that in integration testing, we integrate different units, okay? Once we have all those units together, okay, then after that, we basically perform the system testing. And here we use black box type testing that is based on overall requirement specification, covers all combined parts of a system. Black box, remember that black box is a testing technique that is used to test the software system functionality according to the requirement specification. Ensures that system meets all functional and business requirements. Business requirements, they are actually the user requirements or the customer requirements. So here system testing is basically ensure that all the requirements, all the functional requirement and all the user requirement or the customer requirement, they are basically fulfilled here. The system test design is derived from the system testing, system design documents, and is used in this phase. As I told you that this is system testing is done or it is executed according to the system test design that we produced during system design document. It can also involve a number of specialized types of uh, tests to check performance. Now also the performance is checked, the efficiency of the software system is checked, okay, in the system design. Sometimes testing is automated using testing tools, okay. There are some tools, there are some software, and they are also used here in the system testing for the same purpose, for testing or for checking the system, done by independent testing group. They are basically done by the testing engineers or testing specialists. Then the acceptance testing. Okay, acceptance testing is actually it is done according to the acceptance test design document that we produce during the requirement analysis of the software system. So here what we do to determine whether a system satisfies its acceptance criteria in business requirement or not. The system that we produced, it will be checked here by the customer that whether it fulfills all the requirements that is being stated during the requirement analysis activity or not. Similar to system testing, in that the whole system is checked. The whole system is checked here, all the functionalities, the requirements, the business requirements is checked here in the acceptance testing, done by real business users. This acceptance testing is done by the business users or by the clients or by the stakeholders. It enables the customer to determine whether to accept the system or not. This is understood, also called as beta testing, application testing, or end user testing. End user testing approach should be performed in it should be performed in real operating environment. In real operating environment, for example, that the software is produced, that the software is developed according to a particular operating system, according to a particular network, or to according to the hardware, okay. So we would provide such environment, and then we would install the software in that environment, and we would test the software system. Customer should be able to perform any test based on their business processes. So basically, because the business processes may composed of many activities, the different transactions that are done in a particular business, so the customer will perform this sort of testing. Final customer signs off. Here the customer would be signs off. If the customer like the software, if the customer is satisfied, if the customer sees all the requirements in the software system, then the customer would be happy and he would be signed off. Otherwise, there will be problem again. The feedback would be given, and based on feedback, requirements would be changed, architectural design would be created, system design would be created, module. So the same activity would be applied again in this acceptance testing. Advantages of V model. Now these are some of the advantages